Great. So I'm happy to introduce Pierre second time. So Pierre is here for 5 days only. It's already his second talk. If every participant of our program gave 2 talks, we had no chance to do anything else, you know. So this Pierre is special. So he will give a special lecture, which is I think about the roots.
About Pythagoras theorem, so it's something you all know. So if you already know the proof, you can go. Okay, so first of all, it's a book that will be published in September that I wrote and completely outside my scope, and I had to learn a lot before I could do that. The book is in French, by the way. It's called Dossier Pythagoras, Pythagoras File, from Shamanism to Quantum Mechanics. The title is a little bit too much. Okay, it's just there to attract the reader so that I can sell my book. But basically, it's a book on Pythagoreanism, from the origin to nowadays, to people like the musician Xenakis, for instance, who said we are all Pythagoreans. Okay, so. At every moment of the history, people have thought of themselves, some people have thought of themselves as Pythagoreans, and for some reason, Newton claimed that Pythagoras had found everything before him, Kepler also, Copernicus also. So this is the theme of the book. But there's one chapter, I thought I'd concentrate on one chapter, which is about Pythagoras theorem, and as the title says, I'll give some reference points to assess the claim that Pythagoras didn't do it, or the Pythagoreans didn't do it, or maybe did it, okay, and where did it come from, etc. So I say what the philology, history, and archeology can say about that. But of course, I'm not a historian, I'm not a philologist, and I'm not an archaeologist. Okay, so if there are people in the room who are specialists of that, I just ask them to be very tolerant towards me. Okay, and but I will try not to say stupid things. And after all, I've not been doing research, of course, in history of archaeology, and I've followed the people which are reliable in this field. Okay, and there are many of them, that I shall quote, and so I think what I extracted from their work is still correct. Also, although when you're dealing with philology, you'll see that philologists never agree. Okay, there's one day one of them will say this sentence was pronounced by so and so, and next day somebody comes, you made a mistake in the translation, and then they start fighting, and then. So all the field is moving, okay? But there are a few things that but I'll mention that in due time. So I'll do it in 3 parts, okay? First part will be is the easy one, okay? Who attributed this famous theorem to Pythagoras? Then who found it, which is easy also, and who proved it, which is more difficult, okay? But I'll give some clues of possible ideas, and I'll tell you right away that I think, and I'm not the only one, but I'll give arguments that really this theorem was known and used, and people knew the proof in the between 450 and 400 before Christ. Okay. Just after Pythagoras died, around 400 before Christ. I think it belongs to his school, and most likely he didn't do it himself, but again, nobody is sure. So I'll give you the clues for this. Okay, so let me first, because it is so first these were written by my friend Takis. Okay. This phrase here, just to show how things are difficult, is a phrase that Pythagoreans pronounce, and it's aftos FI, which means he said it, which means the master said it. every time a Pythagorean was mentioning something, he should say this sentence, okay, because the Pythagorean sect, okay, was considered as a group, and anybody who claimed that he would have done something, okay, would immediately be punished by banishment from the sect. And there was a ritual. They would make a tomb, a grave for him, okay, and then consider him as dead, okay. And in ancient Greece, you could not enter the house of of somebody who was dead, okay, at the point. Also, you could not enter the house where a woman was giving birth, because at these there were two passages for the soul, for the transmigration, okay. At these two moments, the soul could be one way or the other, okay. So it was very dangerous to disturb this process, okay. So if you were considered dead, then people would not go into your house, okay. So it was banishment, a psychological banishment, if you want. So this explains also why nobody wrote in the time of Pythagoras, and that the history is very dark here, okay. So, and the second sentence is one from Heraclitus, and I pronounce harmony aphanis phaneris kriton, just to show you that I can read Greek, okay. But that's so, which means the Takis, you agree, the invisible harmony is better than the real world, okay. This is a sentence by Heraclitus, who lived shortly after Pythagoras, but who knew very well the thesis of Pythagoras, that he criticized. There's a fragment of Heraclitus where he criticized Pythagoras for for knowing too much, okay, in fact, okay. What I believe, this really personal opinion, okay, that Heraclitus was a real philosopher. He knew nothing about mathematics, and not a scientist, certainly, and that he was a little jealous of Pythagoras and his school, okay. And then therefore he knew too much, okay, and this didn't help him, whereas Heraclitus, of course, knew the truth that he could not explain. Well, anyway, this is so you all know the theorem of Pythagoras. I just write it because it's on video, okay? So I like at least to have this this picture here. You know the picture. Okay, so this is a bad thing here. It's the rectangle triangle, and then you build squares on the sides here. So this one I have not room enough, and of course this square is equal to the two square here. Okay. I present it in this way because it just shows to you that it is really it's not obvious. Okay, I think of people at that time. Okay, if you put a rectangle triangle, how could they know that this was true? Okay, it really asks. They must have been very curious and trying things, etc. Okay, so it is. So it may be the first theorem of history, okay, and actually it's almost the first theorem of prehistory, as you will see soon. And so why people said it was Pythagoras who did it? The first time, so there is no good reason for that. The first time it was mentioned that it was a theorem due to Pythagoras is in the book on architecture of the Roman architect Vitruvius, and he was living around 25 before Christ, and he mentioned that in the preface of the ninth volume of this book on architecture. Then there is a mention of it of Plutarchus. Plutarchus lived in the 1st century after Christ, and there is also a vague mention which is recorded by Diogenes Laertius. Diogenes Laertius wrote the history of philosophers, and he lived in the 3rd century after Christ. So there is he wrote about all the philosophers of Greece, including Pythagoras, and he's more or less reliable. And anyway, he mentions a certain Apollodorus, who maybe there's several Apollodorus in Greece who wrote, And this one is maybe Apollodorus of Cyzicum, who lived in the 5th century before Christ. And he mentioned the glorious figure discovered by Pythagoras. But then there are two things. What does it mean? What is the glorious figure? And is it true that this guy lived in the 5th century before Christ? Okay, so we don't know. And then after that, it became fashionable to attribute this theorem to him. And for instance, there is in Porphyrius wrote a life of Pythagoras. There are two lives of Pythagoras which are entirely accessible. Okay, so the one due to Porphyrius and the one due to his student Iamblichus. Okay? And they were what are called Neo-Pythagoreans. Okay? And so, in fact, at this time, the Neo-Pythagoreans, they forgot a little bit about science. They were more interested they were more of the mystical type. Okay? And for instance, Porphyry writes that when he discovered the proposition that the square of the hypotenuse is equal to the squares of the sides containing the right angle, okay, he sacrificed an ox, but the more precise authors say that this ox was made of dough. What interests Porphyrius is not the theorem, okay? It's vegetarianism which interests him, okay? So in fact, he is arguing against people who say that he sacrificed an ox. Again, this was not Pythagorean, and Porphyrius was a vegetarian. So he insisted on the fact that the ox was only made of dough. Okay, so and then, but okay, there is something which is very negative against the idea that Pythagoras found the theorem. You can find that in Proclus. Proclus is one of the last Neoplatonicians or Neo-Pythagoreans, whatever. And he wrote commentaries on of the Euclid's Elements, and there he says something which is negative. He says, if one believes those who want to tell the history of ancient times, one can find some authors among them that attribute this theorem to Pythagoras and make him sacrifice an ox after this discovery. So he said, if one believes, etc. So obviously he's doubtful about this. He doesn't know. But as I tell you, the autos F thing worked, and during the whole history, then from now on, from Vitruvius on, people attributed the theorem to Pythagoras. Okay, without, and this was in all the times, and especially you see him in the cathedrals. Okay, where he's supposed to be a geometer, because Pythagoras appears as a geometer and as a musician. Okay. And this is not, you see, and this is a general tendency, and to explain why people do that is in ancient times it was very good to refer. You would not invent something. Okay? Suppose you find a theorem. Okay? Suppose I find a theorem, then I would be ashamed. Okay, of saying this is my theorem. So I had to tell that this was proven a long time before by somebody who was very important. Okay, and this was the general feature, and this the general psychological feature, and this is you can see even in the case of Newton, for instance, Newton or Kepler also, but Newton here he said in his manuscript notes, which are conserved by the Royal Society, he said that Pythagoras discovered the law of the inverse of the square of vibrating chords, and that he extrapolated this discovery to planets and their distance to the sun. So for him, even what he said, the discoveries of Newton for himself, okay, he must refer to something before him. Kepler did the same thing. He referred to Pythagoras. Copernicus referred to Philolaos or the Pythagoreans. Okay, they always, all these people have done great things, but they were not boasting about them. Okay. So this is this explains, okay, the legend about Pythagoras. Now, where the second part? Okay, so we don't know. Nobody can say something correct about that from the philological point of view. So now, historical point of view. Okay, so we have to or archaeological also. There are several candidates. Okay, there are the Egyptians, the Mesopotamians, and the Indians. Okay, The Egyptians, generally people say, okay, this comes from Egypt, okay, because there's a papyrus which is called the Kahun papyrus, okay, which is conserved in Berlin, where you have the mention of 3 to the square plus 4 to the square equals 5 to the square, and that's all. Okay, so immediately people say, look, this must be the theorem of Pythagoras, but if you think it's not clear, okay, so maybe not, okay, how could it be? I don't know. There's no geometry in that papyrus. And the other, there are only 2 other famous papyrus in Egypt: the Rhind papyrus, which was, and the Goleshnichev papyrus, one conserved in the British Museum and the other in the Pushkin Museum. And the Rhind papyrus and the Goleshnichev papyrus do not contain anything that is related to Pythagoras' theorem. Okay. There are many things there, and it shows. But they were written. Okay, the Rhind papyrus was written around 2000 before Christ, of course, and it doesn't show. There are mistakes, and people tend to think now that the Egyptians did not do much. At least nothing much is recorded. But for the Mesopotamians, it's completely different, and of course this was started to be known at the beginning of the last century or the end of the century before that, when people made archaeological discoveries. And then there is one, for instance, there is one. You know that these famous tablets made of clay, where the students wrote the solutions of problems, where some problems were solved. And there was one of them which is particularly striking. It's called BM 85194. BM means British Museum, and it dates from the Hammurabi period. Hammurabi period is 1700 before Christ. Okay, and there are a lot of tablets which are conserved from this time, and this tablet has this problem, which is solved here. So it's okay. I use numbers as we do now, because of course you know that the Mesopotamians use sexagesimal numbers, so I save you from this. Okay. The thing says 20 is the circumference, 2 is the perpendicular. Find the chord. Which means that you have a circle, and the circumference they mean in fact diameter, and the perpendicular is this part here, which I call B, is equal to 2, and this diameter equals to 20. And they solve it, and the solution is explicited as an algorithm in the usual way in Mesopotamia. And you see, they're just making this formula, okay, which really clearly shows it is not 3, 4, 5. It's not the classical Pythagorean triangle. It is so they obviously they knew it that it was true in full generality. Okay, a very long time ago, and there are several tablets of this kind. Okay, there's one which dates from the same period. Okay, where they compute, it's a student's exercise. You have a cane here, a stick, okay, which has a given length, and then it's put on the wall like this, and you give this here, and you want to know of how much it has been sliding here. And this again gives Pythagoras' theorem in a way that nobody can contradict, and it is therefore 100% sure that this theorem was known a very, very long time ago by the Mesopotamians. There are also the Indians. Okay, so the Indians is more complicated. Okay, because there are some sutras which are called the Sulba sutras. Sutras, which they mean the book of ropes, something like that. Okay, books of ropes, and you know that. we know this from Democritus. Okay? Democritus was boasting that he was better than the Egyptian Harpido naps. Well, this means Harpidon means rope, and aptine means that you pull the rope. Okay. So the people who made measurements in Egypt, they used a rope. You can see that in many papyrus, a rope, and there were some marks, and then they were supposed to have the 3, 4, 5. But nobody knows, okay, but people inferred that from Democritus that they were using these ropes to do some geometry. Okay, and it's true that maybe the first geometers, which were people measuring fields or temples, etc., might have used this kind of method. But again, nobody knows. But then you see, the strange thing is that you see that here in India, you have the book of ropes, which belong to bigger books where you have we describe the rituals, how to build an altar, for instance, and things like that. Okay, because you have to be very careful, because it was very dangerous if you don't follow the ritual exactly. And there is one of these there are several of them. The famous Sulba Sutra is the Apastamba Sulba Sutra, and it dates around the 5th before Christ. The one that we, at least if we follow Heath, who was last century historian of Greek history, then in this he mentioned the construction of how to double, for instance, how to double. Sorry, if you have 2 squares here, okay, how to construct 1 square, which is the sum of these, okay, and then the solution which is given is you put the small square here, okay, and you just do this here, and you construct the square in here, okay. And also they mentioned the Pythagorean triple 5, 12, 13, not 3, 4, 5, okay, which is kind of surprising because it is the first one that comes to mind, but this one is the one mentioned by in these sutras. So maybe was it after? Was it before the Mesopotamians? Did they learn that from the Mesopotamians? Okay, again, nobody knows. Okay, there is nothing. It's very. The thing with Mesopotamia, archaeologists have been very lucky because they have a lot of records. Okay, really a lot of records, and the collection is increasing. So maybe people will know more about that soon. By the way, because I would like to show you connections towards the end, I'll show you connections. All Greece, India, Mesopotamia were connected. This thing about altars, okay, you have to construct altars of a given size. Okay, for instance, one of the prescriptions was construct an altar which is the double of this in surface, okay, of this one. And then you all know about the problem of Delos, okay, of doubling the cubic altar, okay, which presented many difficulties, okay, even for the Greeks, okay, and so maybe it comes from there. Who knows? Okay, maybe it comes from this part of the world, the idea here, and this problem is explained by a guy with Theo of Smyrna, who lives in the 2nd century, in a preface of his book, which is called Expositions, where he quotes a text of Eratosthenes. The text is called Platonicos, and in this text he explained why that this was a request of the oracle of Delphi, because some kind of plague had occurred, and there was something to be done. And the oracle said, double the volume of the altar in Delft. Okay, so and Plato quotes this and saying he said that because to make the Greeks ashamed because they didn't learn geometry, especially geometry in space. Okay, so this was the beginning. Really, at that time, Plato was trying to understand geometry in space, and he learned from Archytas. Archytas was a famous Pythagorean, okay, who was really a mathematician, and so he discovered that, and he wanted people to learn about that. So this is what can be said about archaeology, and there is at least one answer was known a long time ago by the Mesopotamians, but of course no proof. You see, the Mesopotamians, they wrote their tablets already always as algorithms. In what there are three types of tablets. Okay, there's the tablets on divination, which divination can be by looking at the liver of a sheep, okay, of a sacrificial sheep, or it can be by looking at the stars, etc. Okay, so they were champions of divination. Okay, and they had also medical tablets. Okay, and they have mathematical tablets, and they are all built on the same way. Do this, okay, and then you find, and that is the method. Okay, they always say that is the method. You have to apply, and in mathematics, obviously they knew the result. Okay, but it was not put in. They didn't apply formulas or things of that kind. So now, what about the Greeks? What did they do? What Pythagoras do? What his school did? And you see, then, frankly, if you read the literature there, you see everybody is contradicting everybody else. Okay, and so there are people who are pro-Pythagoreans and against Pythagoras, and for reasons which are, I don't believe, scientific. Okay, actually, in my book, I show that this had a lot to do with the Christians. Okay, that blurred the thing. But anyway, so you have people like Erich Frank, who wrote in 1923 a book which is called Plato und die sogenannten Pythagoreer, Plato and the so-called Pythagoreer. Already when you see people talking about the Aristotle speaks of the so-called Pythagoreans, but he didn't mean it in a way that was pejorative. But people who don't like Pythagoras, then they translate it the so-called Pythagoreans. So to give you the idea that they were it was a pejorative thing. Okay, and in fact, he just say people who claim that they are who admit that they are Pythagoreans. Okay, or Pythagoreans. Okay, that's what he said. So Erich Frank was a very influential historian. Said that all the discoveries attributed to Pythagoras or his disciples were in fact due to some mathematical school in South Italy in the time of Plato. But this is a ridiculous statement, okay, because there was Archytas who was in the south of Italy, and he's a Pythagorean. Now people, they say, okay, maybe Archytas was not a Pythagorean, okay, and then they argue. But recently there have been books by Karl Hoffmann on Archytas and this thing, and it's considered really he was a Pythagorean. Okay, there are many facts that point to that, and not only mathematically, but in his way of life, etc. We see this kind of statement you find all the time. Now people discuss. Aristotle spoke a lot about Pythagoreans that he didn't like. Okay, he didn't like them, maybe for one good reason. Okay, because he didn't like Plato himself, because Plato didn't put him at the head of the the academy when he didn't had his nephew Speusippos to be at the head of the academy, and Speusippos was Pythagoreans writing about numbers, etc. Okay, and so I don't know, but he didn't like him. But there are fragments of Aristotle. So the positive fragments are like this one, okay, fragment 191. I don't think it interests you to know, but he said after these men, chronologically, this man is Democritus. Leucippus. No. After these men, I don't remember what it was. Chronologically, Pythagoras, the son of Nicarchus, first worked at mathematics and numbers, but at some later period, he also indulged in miracle mongering like that of Pherecydes. Pherecydes was an Orphic writer, okay, mystical writer. And everybody was making miracles at this time. Okay, so in here it seems to be positive. It seems to say he was a mathematician really, and the miracles that he was supposed to have done and that people didn't believe in, he did after. Okay, but then if you read the philologies, which is really the reference in all these things. It's Walter Burkert, who wrote Law and Science in Ancient Pythagoreanism. Then he dismisses this fragment. He says it's not a fragment from Aristotle. Okay, don't believe people who told you it was. Well, I have no. I think people believe that he is right, okay, that this fragment is not good. So let's take another fragment. Another fragment about Pythagoras is the famous catalogue of geometers of Proclus, and which is attributed to Evdemos. Evdemos was a pupil of Aristotle who wrote the History of Mathematics. Okay. But of course, you don't find his History of Mathematics. You only find fragments and quotations from elsewhere. And in this fragment, the famous one, he says Pythagoras. So he gives Thales first, okay, and maybe one or two after him, and then Pythagoras turned geometry's philosophy into a form of liberal education, seeking its first principles from a higher source and hunting out its laws by a non-materialistic and intellectual procedure. So this is considered as the act of birth of pure mathematics, okay, in everywhere. But then Walter Burkert examines that in detail, and he can prove that this sentence was taken from Neo-Pythagorean, okay, which is Iamblichus. And he said, no, then we cannot believe that. Okay, but there is one thing maybe he forgets. Okay, Proclus, they had texts for him. Okay, he was a Neo-Pythagorean and Neoplatonician, in fact, and there must have been something in Eudemus, okay, about Pythagoras somewhere in his catalogue. Okay, so this was exactly the place where it should be. So maybe and Eudemus speaks of the Pythagoreans several times. We'll see that. So maybe it's in this case, it's Proclus just slightly changed it to Pythagoras. Okay, which is of course he shouldn't have done that. Okay, but it doesn't mean that there was no Pythagorean here. Okay, that they were not involved in geometry, of course. And then there is. Then another fragment of Aristotle in Metaphysics, who said that contemporary of these philosophers, and before them, those who call themselves Pythagoreans, were the first to introduce mathematics. They made this science advance, and having been brought up in this science, they thought that these principles were the principles of all things. Okay, this. Now, Burkert argues against that. Say he didn't mean that. He just meant that they connected mathematics with philosophy. Okay, and, but the fragment he accepts, okay, as true, but it's only the interpretation. Okay? But if you can give many interpretations to that, and if Aristotle said they made this science advance, okay, it means that there were Pythagoreans who made some research in mathematics. So this is all I want to know. Okay, I don't need to know if it's because they introduced mathematics in philosophy or whatever. They obviously made advances, and this is not. So there were Pythagorean mathematicians, okay, who made this science, and it doesn't quote only Archytas, okay, but he quotes in general, okay, these people. So what can we say about what could have they been doing, okay? So you find in many fragments which are maybe dubious fragments, but people say, okay, the Pythagoreans did the theorem of Pythagoras, okay. They did the dodecahedron, okay, which is not quite true, okay, but they were considering what is called Platonician solids or perfect solids, and also the application of areas. So application of areas, in general, when people read about I mean, people who are not specialists, of course, when the general public reads about that, then application of areas, what does it mean? Okay, they don't go, and it's a strange thing, but it's a very important thing, because first of all, it is clear that the application of areas is Pythagorean. Okay, because of what F. de Moos says these things are ancient and are discoveries of the Pythagoreans, of the Pythagorean muse, okay, which means the Pythagoreans, and he says, I mean the application of areas, etc. So this text, this fragment is not, nobody argues against it, and I will show you why this is important, because in the application of areas is to transform some a given figure into a square. Okay, so already squaring the circle should be one consequence of this theory. Okay, if it worked to the end. What the Pythagoreans did is they showed that you could transform any polygonal figure into a square using, of course, ruler and compass only. And this was when was this done? First of all, and then first of all, I'll show to you that this the theorem that you find in Euclid. Okay, so supposing that that gives the final solution, use the theorem of Pythagoras in an essential way. Okay? It is. And therefore, the people who did it must have known and maybe known the proof of the theorem, because the Pythagoreans would not use a theorem if they didn't know the proof. Okay, they were very for that. Okay, they say they had to prove things. Okay, and so they could not avoid proving that. So I'll show to you what application of areas says. But in order to give historical perspective, we must see when this was this discovery of the theory of application of areas done. Then there's one date, which is the in 444 in Aristophanes. The birds, okay, in his play, okay, in his comedy, The Birds, he won the prize in 415. There is some. I try to have the exact quotation because it's kind of. I hope I didn't miss it. There is a guy in the play which is called Meton, and who is mocked by Aristophanes, because this guy is trying to square the circle. Okay, I don't know where I put this quotation. Well, anyway, no. Okay, it looks like this. Okay, so the guy says, I shall take, it's a comedy, okay, so mathematically it's not very good. I shall take my dimensions with a straight ruler, applying this curved ruler from above in such a way that the circle becomes a square. Okay, so the circling of the square is mentioned by Aristophanes, and in such a way that you can maybe believe that it was already supposed an impossible problem, that the Greeks had already the impression that it was impossible, okay, that it was too difficult. So this is 414. And then, so the guy who came close to this before was Hippocrates of Chios, who lived in Athens between 450 and 430. He was in Athens at this time, and he was able to do the quadrature of the lunule here, which okay, I won't go into the detail here because you maybe know this proof here, but this proof maybe I'll come back later. Is based on the argument that two homotetical figures where the ratio of homotety is k, the surface is in the ratio k to the square. Okay, so this is the basic idea of this of the proof of Hippocrates. We will need it later. So Hippocrates was there. So therefore, it must have been before that time that the people in the Pythagorean school made this discovery. So maybe before 430, which is the late date, or maybe before 450. Now, if you look at the history, okay, of the Pythagorean school in South Italy, you know that Pythagoras came from Samos, and he arrived in Crotone, which is in South Italy, in the let's say 530, okay, 530, and at this time some people say 510, okay, but most likely 530 for many reasons, and he died around 500 or maybe 490, let's say 500. And then the Pythagoreans were very active politically in the region. So his sect was very active, and they were people who were really in power in many cities in South Italy. And then, since these people were not quite democrats, okay, they were not, they were elitists, and people didn't like them. And after some time, okay, in 450, there already had been troubles before, but in 450, maybe 454, then there was an upheaval in South Italy, and they burnt one famous episode. They burnt the Synedrion, okay, the meeting place of the Pythagoreans. Okay, and this was from this time the Pythagoreans were not so well in South Italy, except in Taras, in Tarentum, if you want, where Aquitas was, okay, where they could continue to prosper. Okay, but and then they migrated to, some of them to Athens, some of them stayed. But you can imagine that at this time there was still, the sect was still very strong, okay, and maybe doing some scientific work. Okay, so it could be this somewhere in this period. Of course, I don't offer a solution, okay, because nobody can, but it points to this fact. So now, what about the theory of application of areas? Okay, these are theorems which you find in Euclid. Okay, this proposition, it says the following. Okay, so I have segment AB, C is the center, and D is somewhere here. Now I construct the square on CB here, and this rectangle here. And the theorem says, is a strange theorem, but it says that this area here that I've made here, these are squares, okay? this is a square, so which is equal to the length of this. Okay, these two, this is equal to this in area. Okay. Now don't look at the detail, but what just to mention that if you translate it in algebraic notations, you obtain something which looks like the completion of the squares in the solution of the equation of second degree. Okay. This is very important to remark because the Mesopotamians knew how to do that. Okay. There are tablets where they clearly show that they knew how to do that. Okay. And okay, that's the first part. Now the crucial part here is Euclid showed somewhere else that any polygon you could transform in a rectangle. So now the last part was how to put a rectangle into a square. Okay? And this is, okay, here you have this rectangle here. You take this equal to this, okay? And then you take the center of BF, you build, you construct the circle, and then you put H here, okay? And the solution is that EH, the square constructed on EH, is equal to this rectangular in terms of area. Well, pass the proof is not very important, okay? If you want, it's not, it takes a few lines, okay? And it use at this point here the theorem of Pythagoras, because you have to say that GH square is equal to this square plus this square, okay? And this is exactly, and this is really the central part of the theorem. So, and you always have to use the Pythagoras theorem, okay, to prove that, okay. Whatever way, okay, there is no escape. Okay? So this application of areas uses Pythagoras theorem. It was made by Pythagoreans, and therefore Pythagoreans knew the proof of Pythagoras theorem. Okay, that's one conclusion that you can draw. Now, what about the proofs of? There is something one can say about the proofs of the theorem. There's another argument that it was Pythagorean. Is the following. You know, there are three basic proofs, okay, and many of them are just modifications of them. One is the proof in Euclid. Proof in Euclid, you can still consider it as an application of areas in some way, but it's too complicated. It's very clever, but it's too complicated, I think, for people in that time. There are more simple proofs. One of the proofs is, is the homothétical proof. Okay, sorry, I should do something like this. Okay. This is now. If you can show that these triangles are similar, this one, and the big one, okay, then the theorem of Pythagoras just comes from the fact that two figures which are in a homothétical ratio k, the surface is the area is in the ratio k to the square. Okay. Now, if you want to prove this, that they are similar, you must use the theorem of that the sum of the angles in a triangle is equal to two right angles. Okay. But then if you, let's go back to F-demos. F-demos says this theorem, again, is a Pythagorean theorem. It's a Pythagorean theorem, and nobody, no philologists claimed anything against this, okay? So it is a Pythagorean theorem. So this is one, and shortly after, comes Hippocrates of Chios, who use, in this case, you use a very simple form of this theorem of homothéty, okay? Because you are dealing with rectangles or half rectangles. So this is completely obvious, okay? you don't really need a proof. But then Hippocrates, of course, went a little bit further. And if you look at this proof, okay, he has an isosceles rectangle. And what he does, he says, I have this, and this, okay. And what he said in Hippocrates is that this is equal to this plus this. Okay. He doesn't put square; he puts half circles in the time. So it's really a proof which he knew of something before. He should have, if he was able to do that, he was able to do this proof. Okay. If he didn't mention that, it's because it was made before him. Okay, maybe. Okay. So by whom? By the Pythagorean, who had the right theorem, which is attributed to the Pythagorean, that the sum of the angles is equal to 2D. Second proof, I made third proof because Euclid's proof I put aside, is the famous picture here. So I put it, my drawing is not very nice, okay? But it's good that it's not so nice because the proof here is based on the fact that this is a square. Okay, so generally when you present the proof, you do a nice drawing and it's obvious that it is a square, okay, from sight. But in fact, you have to prove that it's a square to make the proof. And again, to prove that it is a square, you must use the sum of the angles of the triangle is equal to two right angles, okay. So this is another candidate for the Pythagoreans to prove, okay. So of course, there is no. It's only a perspective, okay? It's not. So now we are talking about Pythagoreans. Of course, it's not Pythagoras himself, okay? So let's try to push things a little further, okay? And see, this is now it becomes more dangerous. And say it was because people of Walter Burkert, it's very clear Pythagoras no mathematics. It's a joke. It's folklore. He was a shaman talking with dead people. Okay, and nothing else. But that's incredible because first of all, historically, you must realize that geometry was already developed in the time of the youth of Pythagoras, not by Thales. Thales is an invention of Aristotle. All the theorems which are attributed to Thales come later because there were before the Pythagoreans, and you needed to have some basic facts about geometry, like this here, okay, where this is equal to this. This is attributed to Thales. That this he says that the diameter cuts the circle into equal parts, which why not? He says basic things like that, and they were just put there just to show that there was something. You didn't start from nothing. Okay? That there was some basic elementary geometry at his time, and it was attributed to Thales. And of course, the Greeks knew that if they had the idea of drawing a circle or whatever, they knew that. But Thales is an invention, I think, but nevertheless, starting from Thales, and maybe due to the Egyptians, okay, maybe due to the fact that the Greeks could go easily to Egypt at that time. They had a comptoir, a place which was called Naucratis, where they could make business with the Egyptians very easily. So they must have admired the Egyptians for the architecture, so maybe they were interested in geometrical facts, elementary facts at this time. But nevertheless, they didn't. There's not much about Thales that we know, but we know that, for instance, when of course Pythagoras was born in Samos, okay, and Samos south of Samos, there's a little city which is called now Pythagoras, okay, which was in the ancient times the city of Samos, where he was born and where he lived. Okay, before he departed for South Italy. And at that time, there's a famous thing in Samos. It's called the Tunnel of Eufalinos. It's a tunnel which is built in the mountain, and it has been built. The workers started here, some others started here, and there's just a slight discrepancy of maybe 2 or 3 meters there, okay, where they had to make corrections, okay, and they didn't go out of the earth to see if they were right, okay, so it must have been they must have used a geometrical construction for that, okay, they must have been using some geometry. What I mean here, that they were precise enough and they were precise enough, and that there were geometers somewhere. This guy, this work was required a lot of money, and the people who asked for him to do this work, they must have asked, "How are you going to do this before?" Okay, and he must have done some drawing somewhere with geometry. Okay, which means that what I mean by that is that this is a kind of architectural feat that you cannot produce without knowing a little bit of geometry. And Pythagoras was, at this time when it was built, he was an adolescent or maybe a young man, and there is no reason why he shouldn't have talked to these people, to the engineers at this time, okay, and maybe got interested in that. Whatever, okay. Pythagoras was also now if you think about what would have been the role of Pythagoras in the history of Greek mathematics, I think his role was really the transfer of Mesopotamian knowledge to Greece and the transformation of this knowledge, okay, a new philosophy about this knowledge, because Pythagoras is born in 570, around that. At this time, there were already contacts with Persia, okay, but not so many. So the contacts could have occurred when the Persians, when Cyrus the Great invaded Ionia, okay, Ionia, and this was in 546, okay. And at this time, and Pythagoras stayed there up until 532. So he may, so the Greeks could have contacts with the Persians, and also you have to see that not only Cyrus conquered Ionia, but he also extended his kingdom to India also. And every year there was a festival in Persepolis where people would meet. And the Greeks were curious people, okay, so they could have learned that. Most likely there have been a transfer of knowledge at this time, okay, towards Greece, and I think Pythagoras is one one of the guys who did it. Why should we believe that? It's because also of for instance, when we speak of Pythagorean triples, okay, there is a tablet of which dates also from the times of Hammurabi or maybe before, which is called the Plimpton tablet, Plimpton 22 or 322, I don't recall, which shows that they knew how to compute Pythagorean triples, and that maybe. So some people are arguing that they had the formula of Euclid, okay, they knew how to construct all the Pythagorean triples. People are arguing against or for that, okay, but still it is true that they were interested in Pythagorean triples. Of course, they were not Pythagoreans at that time. And also there is in Pythagoras, in the ancient Pythagoreanism, a thing which is characteristic, okay, is the use of numbers, the use of figure numbers. Okay, they represented numbers by squares of points, etc. And for instance, there is this famous proof of the formula 1 plus 2 plus n equal 1/2 n plus 1. Okay, this proof is very easy when you use this thing here. These are not, of course, I'm not saying that Pythagoras or people knew, I don't know. Because this, in fact, is, you can see that in the book of Nicomachus Gerasa, who was a Neo-Pythagorean of the 1st century after Christ, and he wrote a book on arithmetics where all these things are. Maybe Speusippos knew about this also, but it's not clear. Anyway, this is considered as it is a specialty of the Pythagoreans, this kind of numbers here. And you see that, for instance, you obtain this type of formula. And then, again, in Mesopotamia, there are tablets, many tablets who give formulas of this type, okay, more complicated formulas. And nobody knows really, they just give the formula, and nobody knows how they did that, okay? So maybe they did this in this form, and maybe it is possible that when these people met, when two, say, a Mesopotamian mathematician, okay, he was training his students, but they knew the proof of these things, okay? They must have known them, they must have arguments for that, okay? So it was easy to transfer that, and then maybe it came to Greece in this way. And in Greece it became something famous with Pythagoras because of this thing here, which is the symbol of ancient Pythagoreanism, which is called the tetractys. And it's 10 things put together, 1, 2, 3, 4. And this was a symbol of Pythagoras because it has the in music, and Pythagoras was known in Greece as a musician also, okay, that he made a theory of music, that he discovered, okay, that for instance the unison is the same note, okay, is a frequency 1, 1, then you have the octave here, 2 to 1, and then you'd have 3 to 2, which was the quart. Quart, I don't know how you say in English for okay, the fifth. Sorry, it is the fifth, the quint. Okay, sorry, it's not. And you have the quart, which is 4 third, 4 and 133. This is over there. Okay, 4 third and 3 and 2. Okay, this is the fourth. And this is the fifth. Okay. So Pythagoras is credited, his school at least, okay, certainly his school, and this in the very early Pythagoreanism is credited for promoting this thing here, that things where everything was number, because in particular they found this ratio for the notes. Okay. So and this, okay, represented this value of the this is 2 to 1, 3 to 2, 4 to 3, okay. So it represented also, and the sum was equal to 10. So already you find this formula here, 1, 2 to n is equal to 10, okay. And 10 was for the Pythagorean, it was the number, okay. So they wrote books about that. Speusippos wrote books about the decade, etc. And so all these things, okay, point to many relations between Mesopotamians and Greeks. Okay, I don't go into details, okay, but there are many things like that, okay. And so if I was to make a conclusion, because now it's time, I would say that okay, Pythagoras was in a sense a mathematician, maybe not exactly of the type we are used to now, okay, but he was interested in mathematics, and he got that from the Mesopotamians. the music of the spheres, for instance, okay, which is associated to Pythagoras, you have to think that again the Mesopotamians gave numbers to the planets. Okay, they gave number to the planet. They had a way which is very close to the Kabbalistic way of deciphering the universe. Okay, with numbers associated to stars, etc., which is also very Pythagorean if you look at that. And they so the music of the spheres comes from the idea that the planets have numbers, and you have to do something with these numbers. Okay, so it became maybe the music of the spheres. Pythagoras, a primitive mathematician, but mathematician. Okay, but there's a lot of blurring due to mysticism and to part of the people in his school who were, in our terms, crazy, and the other were more mathematicians. Is another way of being crazy. But there were two groups, okay, of people, and from him, he got the people around him in his sect interested in mathematics, starting to play about mathematics, and then maybe he taught them mathematics that the Mesopotamians knew. And then this Pythagorean school did real mathematics, the first theorems, okay, like application of eras, and then after that started the real the mathematics as we know them, okay, with people like Hippocrates, etc., okay, and the school around Plato, and then there is the rest of the story. So all this is, of course, very hypothetical, but I think it gives you at least a view of what may have happened in these times. Okay, okay, that's all I will mention.
Thanks, Pierre, for this. Any questions, suggestions, comments, ideas?
How about the Aztec Indians?
The what?
The South Americans, Aztec.
I don't know. I don't know.
What do you know about them?
How much? There was some possible connection between them and the Egyptians, and back. I understand. This has to do with the embalming process to make the mummies,
Yeah.
and there's some evidence of travel between South America and the Old World. But I don't know if there's what mathematics, if any, that survived.
Well, maybe it has to do with shamanism, okay, because it's in Siberia and the Altai, there's a big tradition of shamanism which is still alive now, okay, and these people traveled to America, to North America first, where there are many shamans. There are also many shamans in South America, and shamanism is about is connecting to the dead, and the conservation of the corpses was something which is in every civilization, okay, especially in the shamans. Okay, they would cover the important people with gold, for instance, and again Pythagoras was supposed to have a thigh which was covered with gold, okay, which is of course a legend, but which is clearly shows that he was considered as a shaman. And he did also he would go to do catabasis, which means that he would go to hell to see people and then come back. Okay, all these are to underground. Yes, yes, to hell. Sorry, it's Christian. Yeah.
You mentioned that they doubted Thales' what? Thales' theorems on the existence of Thales himself.
No, Thales existed.
No, but what they doubted that this simple proposition.
Okay, people say yes, because if you the proposition attributed to Thales, but nowhere it is said. Only much later. Okay. So it's just maybe to fill a gap, okay, in the history of mathematics, okay. And then see, Eudemus, okay, he had to start from somewhere, And at this time, the Greeks ignored completely Mesopotamia. Okay, first of all, they didn't like too much the Assyrians or the Persians, rather, and they only thought about Egypt. Okay, they were having active trade with Egypt, and Egyptians and Greeks were in mutual admiration. Okay, they were really good friends, and so this explains, okay, why so much importance was given to Thales having learned in Egypt, even Pythagoras having been in Egypt, which is maybe happened, okay, but maybe not. It's not. So there's the historical bias at this time, because it seemed that the Egyptians were not so good. Okay, at least it doesn't show in the archaeological documents.
And one other comment, you mentioned that even at the time of Kepler, they would attribute mathematical findings to Pythagoras.
Well, that should be everything to Pythagoras. Okay?
But you know, or there were some doubts about him even then. But I think the reasons must have been different because 1,000 years had passed.
Yes. Well, in the time of Kepler and Newton, you see, there was Christianism and Pythagoreanism. What does it say? It says, okay, there is a cosmic order. There is a cosmic order that we need to discover by asceticism, okay, by training. And the guy who made the universe had to obey these rules, okay, the cosmic rules. For the Christian, it's not true. It's God created the rules and he built the world according to that. And this was always, in the whole history, there was always this quarrel between Christians and Pythagoreans, okay, of any sort. And in fact, it's not Pythagorean, but everybody who was hostile to Christians would claim himself as a Pythagorean. Like Newton was a visceral anti-papist, okay, he was a Pythagorean. Kepler also didn't like the Catholics too much, so he was a Pythagorean, etc., etc. Every time they could argue, and also the Christians have spent all their time trying to attract everything into their philosophy or religion. So at one point they liked very much Pythagoras, okay, but then progressively they discovered that he was not politically correct, okay. So there have been many. It went back and forth. There's this. I'm talking about that in my book. This love-hate history between Christians and Pythagoreans with quotation marks, okay, because who is Pythagorean? Okay.
Many thanks.